David Scott is a senior VP and general manager of HP Storage and a longtime friend of Nth Generation. Nth is known, as you know, back in the early days as a storage-focused company. We've, of course, expanded dramatically decades ago into servers and virtualization, cloud, mobility, security, and end-user computing. So no longer are we simply a storage company, but that's bedrock, kind of heart and soul of Nth's DNA. And David's been a part of HP Storage for many, many years. He's currently responsible for $4 billion in business, $4 billion in annual revenues for HP Storage technology a year. That's a pretty big company within a company. Meg Whitman mentioned the importance of scale in this industry. Small companies can do well, but if you're going to bet your business on particular storage, you want one that's going to be here tomorrow and servicing and supporting and upgrading and enhancing their technologies. HP is that company. Very strong in the storage space. Prior to joining HP, David was president and CEO of 3PAR. So that might give you a sense of transition and consistency. He led the company from the early stage enterprise storage offering that they had through a successful IPO. And that was in November of 2007. Under his guidance, 3PAR defined and introduced utility storage. So when you hear that term, that really is a concept that I think was pretty much introduced by 3PAR. 30 years experience in the enterprise storage, software and server market. Previously the general manager of HP's XP enterprise storage business. And that generated over $1 billion in sales for HP in the space of about 21 months since, from the date it was introduced. Pretty remarkable. Prior to that role, David has held various marketing, business strategy, sales, systems engineering positions at HP, in HP UX software, enterprise storage businesses both in the US and the UK. He has a bachelor's degree and with honors in computer science and math from Bristol University in the UK. And help me welcome, if you will, David Scott, Senior VP and GM of HP Storage.
How's everyone? Good conference so far? Yep. Well, I'm delighted to be here. Indeed, Nth Generation is a very important partner of ours, and I really have enjoyed the opportunity to come here today to share some detail with you about our overall strategy within storage. We're going through a massive transformation right now, and in fact, what we're trying to do is align our delivery of storage solutions to the new style of IT that Meg was talking about yesterday, sorry, apologies. Part of that transformation is really driven around understanding some of the tremendous difficulties customers face today with storage solutions from the traditional independent legacy vendors. It's a world that I call a world of fragmented complexity. If you look, and I just had to pick on EMC, it's my favorite company to pick on. If you look at EMC today, just in the areas of primary storage, they have 5 different architectures. VMAX if you want tier 1 mission critical storage, VNX if you want something in the mid-range, VNXE if you want a low-end solution. If you want to go into the world of all flash, they've purchased a new company called Extreme.io with yet a different architecture. And to put it all together, you have the VPlex architecture. Fundamentally, 5 different primary storage architectures where you have to learn, more training, different approaches to manageability, difficulty in interoperability if you're a company of any size that needs different types of platforms within it. Difficulty replicating between all of these environments. And this complexity adds cost and prevents you being agile within your own enterprises. And if it was just primary storage, you maybe give somebody a pass. But if you look at the whole space of backup, as well as information protection and information retention, you have 5 different architectures there, whether you're trying to have a scale-out file system, or an object-based solution, or something designed for the cloud, and even 2 different disk-based backup solutions. This fragmented complexity, we believe at HP, is not sustainable. And so we've been busily trying to transform HP storage to be able to deliver the opposite of this. What we believe is that we've invested very heavily over the last 3 or 4 years in modern storage architectures that have a characteristic that they are what is called polymorphic. You may not have heard of the term polymorphic applied to storage ever before. What do I mean by it? A polymorphic architecture is an architecture that can be expressed in many different shapes and sizes. A single architecture, so a common set of data services, but one that can be expressed as a high-end tier 1 mission-critical platform, as a mid-range platform where value matters, as an entry-level platform, or in the old world of new all-flash arrays. Fundamentally, the same approach to management, same approach to training, easy interoperability, easy replication. And we think the benefits of delivering polymorphic architectures is tremendous simplicity for our customers. And that's why we call the vision for our converged storage platform delivering polymorphic simplicity, the simplicity that comes from polymorphic architectures. And it's not just true in the world of primary storage. We've also done the same with our store once architecture that is designed for information protection, disk-based backup, something that is implementable from the entry level all the way through to the high-end, common architectural approach. And so this is what is very much differentiating the transformed HP storage portfolio from the portfolios of many of the existing vendors today. Now, what is the new style of IT? When you were listening to Meg, possibly she referenced the concept of the software-defined data center. That is one example of the new style of IT. It's about how do you turn around and separate control, i.e. the management and orchestration of your data center, from the underlying data services that deliver data mobility and deliver service to your applications. But in the world of storage, there's also a further separation between the data services that can run either in traditional integrated storage systems, but also the physical underlying hardware. And since x86-based technology like HP's ProLiant offerings have grown in power and capability, there's a further potential to separate and segregate the data services from the underlying physical hardware. What we've done is turn around and looked at the problem set that customers face for this new style of IT and recognized that traditional storage architectures that you see on the right-hand side of this slide were never designed for the software-defined data center. They typically had proprietary management that was tightly integrated into what we call hardware-confined storage. You had to know the underlying physical layout of the storage systems in order to be able to configure them appropriately for the various applications that you have. In the software-defined data center, the whole concept is that you are able to specify at the orchestration level what kind of service that you're expecting to see from your storage devices. And then that orchestration takes place without you having to understand the underlying physical structure. And we fundamentally believe that in order to do that, you need 2 different types of storage system. One of those we're calling software service-refined storage. And service-refined storage is focused on understanding the new world of delivering IT as a service, how you turn around and provide multi-tenant functionality to support that need, how you provide the secure virtual domains between different tenants, and how you deliver a solution that can handle the very unpredictable demands of an IT as a service world. That is a complete solutions approach, but it is enabled by an orchestration level, and that orchestration level is based on open APIs like OpenStack, and I think many of you know that HP is one of the biggest contributors to OpenStack as a management platform. The other type of storage solution for the software-defined data center is what is now being called software-defined storage. And software-defined storage is taking advantage of industry-standard platforms at the physical hardware layer and then running on top of them software-only based solutions as a virtual storage appliance. And typically, those will be hardware-agnostic and even hypervisor-agnostic solutions that can turn your industry-standard servers into rich storage servers in their own right. We fundamentally believe that we have leadership architecture positions in both of these new storage approaches for the software-defined data center. As an example of service-refined storage, it is the 3-path StorServ architecture. It was designed very much from the beginning to meet the service level requirements of public cloud vendors. In fact, 3 out of the top 4 public cloud vendors delivering enterprise applications as a utility service leverage service-refined storage in the form of 3-path StorServ. In the area of software-defined storage, through the acquisition of a company called Left Hand about 4 or 5 years ago, we took a leadership position in deploying software-defined storage in the form of virtual storage appliances. And that is now branded our StorVirtual offering. And we also have extended that into the areas of information protection as well. So whatever you look at, whatever area of this new style of IT associated with the software-defined data center, HP Storage has a rich set of offerings that can meet your needs. And because software-defined data centers have become popularized heavily over the last year or so, we wanted to make sure that it's clear to our customer base that we were thinking about the software-defined data center a long time ago, because in fact 2.5 years ago when we first introduced HP Converged Storage, the picture that you see here, the separation between control, data services and physical hardware, was actually the core architectural definition of HP Converged Storage 2.5 years ago, before even the concept of the software-defined data center came to the fore. And that is something that should give you confidence that HP, through the transformation of HP Storage, is understanding the directions that our customers need to go. So how have we done in the last 2.5 years with our converged storage strategy based on these modern new architectures? Well, if you look at last quarter's performance, we grew our converged storage portfolio 48% year over year, a staggering growth rate. Below that, it was even more impressive. The 3-path StorServ product line grew 82% year over year. And we announced it had achieved $1 billion product-only run rate in last quarter. And that's really because customers have understood the value that modern architectures designed for the IT as a service world can deliver. Beyond that, StorOnce in the first half of the year has grown 50% year over year. In the area of software-defined storage with StorVirtual, we've deployed 170,000 licenses of our StorVirtual VSA, or Virtual Storage Appliance, making us the clear industry leader in that emerging new segment as well. So customers, through their buying patterns, are proving out the value of our converged storage offering. But now let's kind of focus a little more deeply. If you look at the 3-path StorServ, as I mentioned, it's a tier 1 architecture that is designed to address the delivery of IT as a service. And fundamentally, we believe that the concept of eliminating boundaries, artificial boundaries in storage, is really important. And we're delivering the breaking of those and the elimination of those boundaries through these polymorphic architectures. 3PAR started its deployment as a high-end, massively scalable solution when scale matters, scaling up to over a couple of petabytes in a single system with its 10,000 series. We actually created a tremendous revolution in the industry last December when we brought that same architecture down into a platform, the 7000 series, which is focused on when value matters, starting at an entry price point of under $25,000. And in fact, we created even more of a revolution with the 7400 platform, which is the industry's first quad controller platform at under $40,000 that delivers true tier 1 mission critical functionality, which dual controller architectures from all of our competitors like EMC and NetApp simply can't provide. And that is what has made the 7000 series one of the fastest growing product lines in Enterprise Group's entire history. And that has been a benefit, we believe, not just to HP customers, but we've seen a huge amount of deployment of this technology in traditionally EMC or NetApp customers as well. Why has the 7000 been so important? Well, if you look at a customer who wants tier 1 mission critical solutions from EMC, they want to sustain performance after they've had a major hardware failure. They want online upgrades to happen seamlessly. They may want 3-site replication solutions for disaster recovery and business continuity. To implement that, EMC would recommend you deploying an EMC vMax at a cost maybe of millions of dollars. Not the VNX product line that doesn't support any of those requirements. But if you're a small or medium-sized enterprise that can't afford hundreds of thousands or millions of dollars, you have no alternative before the delivery of the 3PAR 7400. Now with a quad controller platform, you can deliver this tier 1 mission critical functionality at mid-range affordability. But we went beyond that, because in the new IT as a service world, with the 7400, we're able to support unpredictable mixed workloads, deliver the multi-tenant security, and also federate different Series 7000s and 10000s together so that you can address your storage plant as a single entity and view it as a single entity rather than a set of individual silos within your data centers. This kind of functionality is not available even on the EMC vMax. But we're able to do this on a platform that, like the mid-range VNX from EMC, delivers both block and file services, but has an entry price point of under $40,000. That is what fundamentally created the revolution in the marketplace with the 7000 series. But let's turn our attention. What now happens when performance matters? Because we've addressed when scale matters and when value matters. But for everybody in this room, you probably started to hear about the importance of flash technology and the way it can address some of the performance needs of your key applications. Well, flash is going to transform the entire storage industry. Do not mistake that fact. And it will happen very, very rapidly over the next few years. And so you have a world where you have a lot of traditional suppliers who deliver general purpose mixed hard disk drive and solid state drive solutions. People like EMC, IBM, NetApp, and Dell. Then you have a set of vendors who are fundamentally focused on building out new architectures that are designed specifically for a flash optimized world. And the reason that you need to do this is that flash solutions really transform the performance requirements in storage systems. They also demand much higher efficiency rates because flash is still more expensive than traditional hard disk drives. So you need to improve the utilization of flash media as much as you can to reduce its overall cost. And then finally, the endurance characteristics of flash-based technology are very different from hard disk drives. Flash-based technology wears out far faster than hard disk drives do. So you have to have an architecture that is able to handle the endurance characteristics of flash. And that's what all of these new startups have been able to do. The problem is that the new startups have none of the tier 1 mission critical capability or the rich data services functionality that many of you as customers will look for. And for the traditional vendors, they don't have the fundamental architectures that are able to support this new flash world. Now, if you don't believe me, just think about pretty much everyone on this list. When EMC went out and considered their architectures, VMAX, VNX, VNXE, they came to the conclusion that they couldn't support an all-flash optimized solution on those architectures. That's why they went out and bought Extreme.io. When IBM went and looked at its storage architectures, they went through the same analysis. Can it support the performance, efficiency, and endurance characteristics of a flash-optimized array? The answer again came back no, and they went out and bought Texas Memory Systems. NetApp has done the same thing and looked through its existing architectures and announced to the world that it has a new, I believe it's called Project Mars, or was called Project Mars at one point, a new architectural design center for flash-optimized arrays. Fundamentally, every single vendor is having to go through this analysis. And one of the advantages that HP has done is that we, with the 3-part StorServ architecture, did exactly the same analysis and recognized that we would be in a unique position in the industry and not have to force our customer base through a migration to a next generation all-flash optimized world. So let's take a couple of examples. If you look at performance acceleration, how do you make sure that the controllers of the system keep up with the performance of flash media? Fundamentally, some of the startups like Violin and Extreme.io, that's what they went after, solving that problem, as well as solving the efficiency problems and the endurance problems. But if you went to look at system resiliency and tier 1 mission critical functionality, that's the capability that neither Violin nor Extreme.io, or in fact any of the other startups in the all-flash world can deliver. And that's what EMC delivers, for instance, with their VMAX arrays. The problem with VMAX is it wasn't an architecture suitable for a flash-optimized world. Only with the 3-part architecture do we have a solution that is both performance optimized due to the 3-part core ASIC design that was built into the architecture very much from the beginning, that allows you to handle the flash performance that exists. It has the characteristics of efficiency. It was a pioneer in thin provisioning technology, so its entire architecture is designed to enable high levels of efficiency and utilization. Because of its architecture, we defined a new system-wide striping and system-wide staring that lowers the wear level on flash media. And so we were able, uniquely, to be in a position where we could apply the 3-part architecture to the all-flash optimized world without any compromise. But we're able to deliver it on a platform that has the tier 1 mission critical functionality, but also the data mobility that is needed to be able to move data through federation between different systems to provide complete agility. Because you may have all flash optimized arrays as well as traditional arrays within your environment, and you want to move applications and data transparently and non-disruptively between both of them. So this literally is a very unique value proposition because what it means for our customers now is that in a single architecture, a polymorphic architecture, you can have solutions that can address your needs, whether scale matters, whether performance matters, or whether value matters, using exactly the same set of rich data services, the same approach to training, the same approach to manageability, common interoperability, and common replication between all of the members of the architecture. And that's really what we delivered with this new 7450 platform. It delivers over 550,000 IOs per second at an extremely low latency of less than 0.7 milliseconds. Now, for some of you, just to put that into context, typically, many primary storage system architectures offer response times in the 2 to 10 millisecond range. So 0.7 milliseconds really can meet the needs of your highest performing application workload requirements. It's extremely efficient. As we mentioned, the 3-PAR architecture was designed with concept of compaction technologies like thin provisioning in mind. And so the architecture delivers the efficiency that's necessary. It's a bulletproof architecture. The 7450 has 4 controllers. So if one controller fails, rather than going into write-through mode, which dual controller architectures go into when one controller fails, and that brings performance all the way down. In the case of the 7450, 3 controllers remain live, you don't go into write-through mode, so performance remains excellent even after a major hardware controller failure. And then finally, it's future-proofed in the fact that not only does it allow you to move to all flash-optimized world, but it also provides all of the peer-to-peer data movement, what we call our peer motion capability, as well as the tier 1 functionality that you as a customer may need. So this performance was really delivered through not only the core architectural benefits of the 3-PAR architecture, but some very specific improvements in our operating system that were targeted at lowering the latency. And by the way, all of these benefits occur not just in the 7450, but they also occur across all of our product line wherever you use solid-state disk or flash-based technology. And what I wanted to suggest is that I believe we have a video where you can hear one of our design architects
times
talk
more
about those
IOs per
advantages.
gigabyte versus HDDs, but require unique handling. We've optimized how controller cache interacts with flash media. For example, we reduce latency and optimize throughput in 2 ways. First, by matching media to host read I/O size, and second, by writing only the cache space changes to flash. We eliminate cache bottlenecks by dynamically adjusting the frequency at which data is offloaded from cache. The mesh active design and specialized 3-PAR ASIC ensure performance for mixed workloads, while the system-wide striping across controllers, ports, and disk mean every application gets the full power of the array. With proactive media management, we constantly monitor flash wear, but because we evenly stripe across every disk, we avoid hotspots that cause media to wear out faster. ASIC-enabled thin technologies have made 3-PAR famous, but are even more critical when dealing with flash. We can run at incredibly high utilization rates in thin mode with virtually no performance impact. And zero-detect capability means wasted blocks are never written to media. We've also added new flash-specific features to speed rebuilds and maintain performance, like using flash-optimized sequential block sizes. Enterprises are always going to need a range of systems to meet application needs. You could approach each workload as a separate silo, but we think simplicity is best. HP Storage really is delivering storage for the next era.
Thank you, Josh. So how do we make this integrate seamlessly, this new all-flash optimized array? Well, first of all, because when you're focused on when performance matters with an all-flash optimized array, and it's a relatively expensive resource, you certainly want to make sure that you can distribute that resource appropriately according to the priorities of your company's business, between different applications and different business units. So one of the things that we introduced also this summer was a new platform capability called priority optimization. It allows you to deliver guaranteed quality of service for different applications and different tenants running against the 7450 array, and in fact every other 3-PAR array as well. So you can say, I want to guarantee this application gets 10,000 IOs per second, or I want to guarantee the application gets a certain level of bandwidth. And in fact, we can have sets of applications assigned to individual tenants or users and oversubscribe applications to those users to give you complete flexibility in the way you distribute the services that are available on the 7450. But you also have the need to move that data online non-disruptively and transparently to running applications, maybe between different 3-part systems within your data center. You may have 10,000s in the data center, you may have other 7,000s there. And here we have our peer motion technology. And this peer motion works very similarly to VMware vMotion. When you want to move a virtual machine from one server to another, you don't have to use some kind of virtualization appliance to move the virtual machine instance from one server to another. In the storage world, traditionally, this has not been possible. In storage, typically you have to use storage virtualization appliances in order to move data non-disruptively from one system to another. We took a leadership position in the industry with a capability called federated storage. Our product name for it is peer motion. And without storage virtualization appliances, which can add cost, which can add complexity and risk to your overall architectural environment, you're able to move an application whilst it's running live from one 3-part system to another. So it gives you tremendous agility to meet service levels at the data center level, because you can fundamentally optimize and do workload balancing at the data center level. You can do utilization optimization at the data center level. You can even do lifecycle asset management, bringing new systems in and retiring old systems at the data center level completely non-disruptively without having to run storage virtualization appliances. So let me move on and just talk about this concept, the second area. I think covered software service refined storage around 3-part. Let's turn the attention to software-defined storage. So software-defined storage, to recap again, is where you leverage industry-standard servers, you run software on it and turn that server into a rich storage services device. And we believe that can be either deployed software only in the form of a virtual storage appliance, or in the case of HP, where we provide our own servers, we can provide it as an integrated, better together appliance, what we call a converged storage appliance, where we bundle the software on top of the industry standard server itself. But the key definition requirement for software-defined storage is that it's available as a software-only platform, because being software-only, it eliminates the vendor lock-in of having to buy the vendor's hardware equipment in order to meet the needs, and it allows you to leverage other industry-standard service solutions. So what do we think are the key requirements of software-defined storage? First, it has to be hardware agnostic. It's got to run on IBM, Dell, HP servers, even ODM servers. Secondly, we believe it has to be hypervisor agnostic. As it runs in a virtual machine, it shouldn't just run in VMware-based environments. It should be able to run in VMware, in Microsoft Hyper-V, in the future maybe even KVM or any of the other hypervisors that exist, so that you're not locked in at the hypervisor level either. And then finally, it should be federated, so you can take instances of virtual storage appliances and cluster them together to scale out and meet and address your storage needs over time. And that's exactly what we do with our virtual storage appliance. As I mentioned before, we deployed 170,000 of these virtual storage appliances over the last 5 years. They offer really rich data services, including high availability, metro cluster-based functionality, and it runs on any individual server and its internal storage or any actual connected storage to that server as well. And by the way, the other element of software-defined storage is that it has to be manageable through open APIs. And in fact, the Store Virtual platform was the first platform that was supported by by the OpenStack movement, providing open management and orchestration of the environment. But we don't believe that software-defined storage should apply just to primary storage. We also believe that it's important to consider information protection as well as information retention in the form of solutions for backup, recovery, and archiving. And in this space, we really have had a leadership position as well with our new architectures. In fact, it's been more than a year since we introduced our source-side deduplication called StorOne's Catalyst on our high-end B6200 platform. This platform scales up to 8 controllers within a single system and was able to deliver the first information protection solution leveraging deduplication that had high availability in it. Every other disk-based solution, if you lose a controller, your backup streams stop. If you're in the middle of recovery, your recovery stops. And you have to wait for someone to come and fix it, and then you have to restart. That can be a disaster if you're in the middle of a recovery. We delivered the first solution that allowed you to turn around and automatically have the system automatically detect a controller had failed and then restart the backup streams and the recovery streams on other controller nodes within the architecture to deliver continuous availability, something that we call an autonomic restart feature. But this platform, more than a year ago, also with StorOne's Catalyst, delivered 3 times faster backup than EMC Data Domain's highest end platform. And for more than a year now, we have maintained that differentiated lead. And in the area of recovery speed, and backup's important, but recovery is everything, we have 5 times faster recovery speed than EMC's fastest platform in their portfolio. So quite literally, you can recover as much data on a B6200 StorOne's platform in 1 working day as it would take EMC to recover in a whole working week. But what happens if you could take that StorOne's functionality, that sophisticated functionality, and bring it into the software-defined storage domain, enable it as storage for the software-defined data center? And that's exactly what we did just a few weeks ago at HP Discover, where we extended this StorOne's architecture, which is also a polymorphic architecture, into the area of software-defined storage with the new StorOne's VSA, or Virtual Storage Appliance. So now, think again, just like the 3-PAR example, you have very high-end B6200 platform family where massive scale performance matters. You have mid-range appliances where value matters. We even integrate the same algorithm in our data protector backup solution. So you can move data non-disruptively between any of these systems without rehydrating the data for replication, disaster recovery, and backup. And then now finally, having a StorOne's VSA implementation that can run on any industry standard server and turn it into a backup device. But we don't just stop with deduplication-based solutions. Backup, recovery, and archive also is heavily dependent and remains heavily dependent on tape. Unlike some vendors where they say tape is dead, only disk-based solutions matter, we do not believe that is the case. And with our StorServ product offering, we just introduced a new generation of LTO6 solutions back in January this year. And we've enhanced our mid-range offering with a new platform we introduced at Discover called the MSL 6480. This is a massively scalable entry-level and mid-range tape library system. You can start with as little as a single drive delivering a low-end solution up to 42 drives capable of delivering over 60 terabytes an hour of backup speed. It can scale from either 80 up to 560 cartridges, delivering a massive 3.5 petabytes of storage within a single system, and you can grow modularly all the way through that. It's extremely simple to manage. You can manage it locally or through web-based solutions, have remote management for multiple different arrays. It's extremely efficient. You can support up to 81 terabytes per single U, so tremendous advantage in terms of overall density. And then finally, it's designed to deliver tremendous resiliency for our customers. It offers enterprise-based key management, but it also has monitoring software that allows it to check the health of the overall tape library system and report that back into your management consoles. So we do not believe tape is dead. Its use case in backup is lessening over time, but also what's happening is its use case in the archive function, where it really is the cold archive storage platform of choice, is increasing. And it's increasing because of its very attractive characteristics. It doesn't use up power or cooling costs, unlike disk drive-based technologies for archive solutions. So we talked about disk-based backup solutions, leveraging deduplication. We've talked about tape. But I also wanted to finish off by talking a bit about information retention for long-term archive. Another aspect of the new style of IT is how do you handle this massive explosion in unstructured information? Not just from how do you back it up quickly enough and recover it, but how do you save it economically over time? And then how do you extract value out of all of this unstructured information that you may have collected? And last December, we introduced a brand new architecture called HP StorAll, which is designed to address this information retention and analytics need for our customers. First of all, it's a hyperscale solution. You can grow it up to 16 petabytes in a single namespace and support billions of objects and files within a single solution. So it really is designed to meet the needs at very low cost of storing that information over time. But part of the secret sauce within the StorAll architecture is work that we did with HP Labs to solve the problems that occur when you had massive repositories of unstructured information. And some of the problems that occur is that people want to do real-time big data analytics on unstructured information. Now we know a bit about that because we own autonomy. And in the case of autonomy, it's very interesting. If you want to ask a question, for instance, on 500 million objects, which of those objects changed over the last 4 hours to do some real-time big data analytics? Do you know how long it can take? 42 hours. That's not real-time big data analytics if it takes you 42 hours to find out and ask you a question, what changed in the last 4 hours. We recognized that this was going to be a major problem for this massive growth of unstructured information for the new style of IT. So we worked with HP Labs to develop a new technology, which is a custom metadatabase that is integrated into HP StorAll that allows you to turn around and rapidly search huge repositories of information. That same question can be answered in just 1.4 seconds using Express Query within StorAll. And it's not just the speed. Previously, autonomy would have taken 20 servers to answer that question. Now, it's a single server to have the solution in 1.4 seconds. So we believe this is a great revolution in the areas of long-term information retention. It's extremely economic. The design of the solution is designed to be able to absorb all of this unstructured information at very low cost over time. So you've heard from me today about some examples of the new style of IT, whether it's storage for the software-defined data center and the concept of software-refined storage with 3PAR as an example, being able to meet the needs of kind of multi-tenant, unpredictable IT as a service environments. You've heard me talk about software-defined storage as another example where you leverage the power of industry-standard servers and deliver rich data services. We've talked about the backup and recovery space and how that can now be applied into software-defined storage as well, and how HP Storage has leadership offerings that solve not only the backup solutions that you may have, but also the long-term archive solutions. And what we think the benefit that we deliver is as follows, what we call delivering you return on investment to the power of 3. The first power is return on information. Leveraging technologies like HP Store All and Express Query, we're able to help you extract information for better decision making out of this massive unstructured information that you have. And we partner very closely with internal partners like Autonomy to deliver value to you as our customers, as well as other ISV solutions. We believe we can deliver you, as a second power, return on infrastructure by being able to boost your utilization efficiency through the use of compaction technologies like thin provisioning, and also deliver you greater agility through federated storage capabilities and our peer motion technologies, allowing you to solve economically problems whether scale matters, performance matters, or value matters for you as a customer. And then finally, we're able to deliver you return on individuals, because you only have single approaches for training in primary storage, single approaches for training in information protection, single approach to manageability, single approach to interoperability, single approach to replication, and leveraging autonomic management techniques where each of these solutions self-manage. That ROI to the power of 3, we believe, is a significant advantage, and it's what means that we're able to deliver you a new area of storage to address the new style of IT. So with that, may I say thank you. I enjoyed being here. Appreciate your time.